I'm Bree.
My name's Jose, and we're going to be making our AC circuit team video.
Hi, my name is Brianna Peoples, and today I'm going to show you how to build an AC circuit on Multisim. First, we're going to start out by placing our AC power source. Then we're going to place our ground. We're going to get a 1 kilo ohm resistor. We're going to get our 4.7 kilo ohm resistor. And turn it counterclockwise. And then we're going to connect all of our components together. Right now we're going to change the neck color for our ground to black. We are going to change our values for our AC power source to 2 volts for our RMS, 1000 hertz for our frequency. We're going to insert our voltmeters, vertical voltmeters. We're changing from from DC to AC on each voltmeter. We're connecting our voltmeters to our circuit. We're adding our oscilloscope to our circuit as well, placing the positive A to the left side of the 1 kilo ohm resistor, the negative side to our ground, placing B positive on the top of the 4.7 kilo ohm resistor. B negative goes on the bottom. We're changing our segment color for our A positive to blue. And we're running our machine. Stopping the simulation, and we're going to look at the results on the oscilloscope. Alright, right now we're going to take a look at our oscilloscope data. We're going to move our cursor back a little bit to focus on the data. We're going to change our scale to zoom in. We're also going to cut out also gonna reverse it so we can view the data more clearly. We're turning off channel B to focus on our channel A, which is reading our voltage source measurement. We're gonna measure our peak to peak first, moving our 2 scale closest to the peak and setting the Y maximum value to the right, setting our Y minimum to the right as well, and we will get 5.648 volts. Now we're going to calculate our frequency used with that 1 millisecond. We're going to calculate our time with the 1 millisecond with our formula 1 over the time. So it's 1 divided by 1 E negative 3, because it's in milliseconds, equals 1000 hertz.
Hello guys, this is Jesus. Now that Brianna has finished with her section on part A on the oscilloscope, I will do the second part on B. First, we're going to rearrange our triggers. We're going to ensure that they are set to the right max values. We just set number 2, and now we'll do number 1 at the middle. Here we got our channel B voltage, which is 4.65 volts, peak to peak. Next, we're going to take our oscope and close out. We'll go to our voltmeter and check and determine if it is relatively close. Now we're going to close out our oscope. We're going to go to our VRMS at 1.649 volts. Next, we'll go to our oscope to look up our time. We're going to change our triggers values to 0. And our second value will also go to 0. And here we will get our time, which is 1 second. Next, we'll close out the oscope. Here we're going to put into our calculator to solve our problem, which is 1 divided by 1. Second, E negative 3 equals 1,000 hertz. Here we're going to be doing the bench portion using the multimeter, function generator, and the oscope. Here we will have the function generator cables. We'll just install right here on the 50 ohm output. Next, we will have the oscope leads. Put one on this second channel, and the next one will go on the first channel. Next, we will take our DMM leads. We will place them into the proper positions, comm, volt, ohm. Next, we are ready to turn on. Starting off, we will set up to ohms. That way we can measure out our resistance on our resistors. That's 1K ohm. 4.6. So we have the correct resistors. Next, you want to ensure that we have the correct leads in place here for the jumpers. Negative, negative, positive. The resistors in positive in line with the other resistor and the other jumper into positive or negative. Next, we will be doing our VRMS, which we will take our oscope lead, our positive to positive on DMM and function generator, negative to negative, ensure that they do not touch. Next, we will change this to AC on volts. We'll ensure that we have 1K ohm. Might take some time going all the way down. Ensure that it is on the depressed position. Ensure that the dBs are in the correct positions as well. This is all the way up to the top. This is all the way down. And from here, we will start maneuvering the amplitude till we get 2 volts here. we have correct VRMS. So next, we'll take our leads off. And we'll start connecting them to the board, starting with the function. Make sure your ground leads always go to ground. For your channel 1, we'll go on this resistor here on the positive leg. Your DMM leads, of course, ground. And we'll go on this resistor here. You can put channel 2, which will go right here. And on ground.
Now that we have gone through and we have built our multisim, gone over our measurements in the multisim, and we have built our bench, let's go ahead and do our measurements on our bench. So we're going to start off with using our real world applications to find our old school method measurements across our VS and our V2. So we're going to start off by looking at our oscilloscope. Now that we have it fully set up, we're going to go ahead and take away our channel 2, and we're only going to be working with our channel 1. So first thing I'm going to do is I'm going to go ahead and centralize it here. I'm going to bring it up to a little bit higher with the scaling just to have it already preset. We're going to start off with our VPP. So the first thing I'm going to do is I'm going to push this, position it horizontally a little bit more in the middle to get it right on that line. And I'm going to drop it down a bit, just to where it's just about touching. Now I'm going to go ahead and I'm going to count these squares. So I'm going to go 1, 2, 3, 4, 5. Now within these 5, we have 5 additional lines in there. So I can see here that it's right at the 4th line, which each of these lines is 0.2. So that means this should be 0.8. So we have a total of 5.8 in our height here. So now that we're going to remember that number, our VPP is going to be, our equation for that will be VPP equals divots, which is what we just counted, times our volts over 1 divot. Okay, so now we're going to write that as 5.8 times, and we're going to look at this voltage right here, right? So it's going to be 1. We're going to put it as 1 volt over 1 divot. All right. So with this, we have our units of measurement. This will be able to cancel all our divots here. And we're going to go ahead and multiply that across. So we're going to use our calculator best friend right here. And we're going to calculate it as 5.8 times 1 just to make sure everything. So we're going to have a total of 5.8 VPP. So now that we have found our VPP, we're going to go ahead and start off with our VRMS measurements. So our VRMS is going to equal our VPP over 2 times 0.707. So we're going to go ahead and write this equation as 5.8 over 2 times 0.707. We're going to go ahead and use our... So now we're going to plug this information right into our calculator here. So we're going to go ahead and hit parentheses, 5.8 divided by 2, close parentheses, times 0.707, enter. And that's going to be our VRMS right there. 2.0503 VRMS, or you can go ahead and write it down as 2.05 VRMS. Okay, now we're going to go ahead and we're going to measure our time. To measure our time, we're going to go back to our oscilloscope here. So the first thing you want to do is go ahead and put this right here to the center line. So we're gonna position it right up here. And then we're gonna position it a little bit horizontally until we see the positive touching the 0 right at the edge here. So now what we're gonna do is we're gonna count straight across until we see the next positive beginning. This is gonna be one full cycle for the time. So we're gonna go 1, 2, 3, 4, 5. All right, so now for our time, we're going to go ahead and put time equals the divots that we counted times the not the voltage, the time that is scaled to over 1 divot. Okay, so we're gonna go ahead and write this here now as 5 times, and we're gonna go right back over here to our oscilloscope. Our oscilloscope said that we were scaled it at 200 milliseconds, microseconds. So we're gonna go type it out, but we're gonna type in the long way version. So we're gonna write it out as 200 times 10 to the negative 6 seconds over 1 divot. So with the divots, we're gonna cancel out that unit of measurement. And now we're gonna plug this back into our calculator here. So we're gonna have 5 times 200 AE to the negative 6 equals, and we go ahead and we get 0.001 seconds. Next, we're gonna measure our frequency. So with our frequency, the formula here is going to be frequency equals 1 over time. So as we already noticed, our time is 0.001 seconds. We're gonna write it down right here, 0.001 seconds equals, plug it right back into our calculator. So 1 divided by 0.001 equals 1000 hertz. So now that we've finished measuring across our VSS, which is our voltage source resistor, we're gonna start measuring across our resistor 2. So we're gonna go back right over here. Now we're gonna go turn channel 2 back on, and we're gonna turn channel 1 off here. So let's go ahead, we're gonna go ahead and raise this up a little bit, right? Make sure that we have it scaled properly to the size that we need. Right, perfect. So we're gonna go ahead and we're gonna start with our VPP just the same way we did it. We're gonna drop it right down to where it's about to touch, and then make sure our middle top is right there. We're gonna start again with counting the squares. So we have 1, 2, 3, 4, and we're right at that 4th line as well. So it's gonna be 4.8, right? So like we remember from our other section, VPP equals divots times our voltage scaling over 1 divot. So we know our divot was 4.8 divots times our scaling, which our scaling for this one is 1 voltage. We'll put 1V over 1 div. Okay, so we're gonna go ahead and cancel out this unit of measurement, and then we're gonna go ahead and plug it right into our calculator again, just out of habit, just to make sure. We're gonna put 4.8 times 1, get 4.8 voltage peak to peak. Now we're gonna go right to our VRMS. As we recalled, our VRMS formula is VPP over 2 times 0.707. So we know what our VPP is, so we're gonna put 4.8 VPP over 2 times 0.707. We'll go ahead and we'll plug that right into our calculator. So 4.8, let's actually go ahead and use our parentheses. 4.8 divided by 2, close parentheses, times 0.707 equals, and we have our V2 RMS will equal now 1.6968 V2 RMS. Or we can also write it as 1.69 V2 RMS. Now we'll go ahead and we'll move right into our time. So like we remembered, our time formula is time equals our time divids times our time scaling over 1 divid. So we're gonna go ahead and go back right here. What we're gonna do, we're gonna position right back again to where the line is touching here. We're gonna move it horizontally till we see the beginning of a positive. Like before, positive is our 1 circle, so our 1 period that we're gonna be counting. So we're gonna go 1, 2, 3, 4, and 5. Right. So we're gonna have 5 divids that we counted times our scaling, which our scaling is 200 microseconds. And we're gonna write it out, 200 times 10 to the negative 6 seconds over 1 divid. So that cancels out our divid unit of measurement, right? And this, now we're gonna go ahead and plug it right back into our calculator again. So 5 times 200 AE to the negative 6 power. Gonna enter that, and that's gonna give us 0.001 seconds. And we're gonna go ahead and do our frequency. Like we talked before, our frequency formula is frequency equals 1 over time. Like we already recalled, the time we have is 0.001 seconds. I'm gonna plug that right into our calculator here. So 1 divided by 0.001 equals 1,000 hertz. Right? And that's gonna be it.
Hi, my name is Jamil, and now that we've gone over reading measurements from the oscilloscope the old school way, I'm now gonna show you how to get measurements using the new school method. First, we're gonna get rid of channel 2 because this is our resistor 2 and we don't need that open right now. So we're gonna press channel 2 twice, and now we're only gonna focus on our voltage source, which is our channel 1. I'm just gonna bring this down just so it looks cleaner and it's even. And now we're gonna look for our voltage peak to peak. We're gonna do that by pressing measure and then scrolling down to voltage. This button pertains to this option. We're gonna click that, and we're gonna scroll down till we see volt peak to peak, which is VPP. I'm gonna press this button in order for it to pop up, and now it's down here. Now this is our voltage peak to peak. Well, actually, we're gonna stop it so we get a clear cut reading. Now, let's read it. So our circuit is running, so that's why this number is bouncing back and forth. We're just gonna go with what we see most common, which is probably about 5.776. Now we're just gonna record that measurement on our table that we printed out. 5.76 volts peak to peak. Now we're gonna look for our VRMS, and we're gonna go back to the oscilloscope and use this menu that we have open in order to find our VRMS. We're gonna click voltage because VRMS has to deal with voltage. And we're gonna scroll all the way down till we see VRMS. Boom, we found it. Click it. And now our VRMS for channel 1 is 1.98 volts. Now that we have that measurement, we're just gonna record it on our table, which is 1.98 volts RMS. Now we're gonna look for our time, measurement of time. And we're gonna do that by going back over to the oscilloscope, and instead of going to voltage, now we're gonna go into the time. So we're gonna look for period because period has to deal with the seconds and the time that we're looking for. I'm gonna click period, and the menu is gonna give us this information, being 1 millisecond. Our oscilloscope is running, so it's fluctuating a little bit, but it's 1 millisecond. So we have 1 millisecond here, and we're gonna record that over on our table over here. 100 milliseconds. And now we're gonna measure the frequency. And measuring the frequency, we're gonna go right back over to the oscilloscope. We're gonna turn the menu on, but we're actually gonna clear the menu so that we have more room to look at our new information that we're bringing in. Our frequency has to do is a time measurement, so we're gonna click time and we're gonna scroll down till we find frequency, which is right under period. So click it, and now we have 1 kilohertz as our frequency. We're just gonna take that measurement and record it down over right here. 1 kilohertz for our frequency. And as you take if you take a look, our new school methods, our new school measurements are just about the same as our old school measurements. So not much really happens in that regard. Moving along, we're gonna look at measurements across resistor 2, starting off with our volts peak to peak. Coming back over to the oscilloscope, we're gonna turn the menu off. We're gonna get rid of this channel because we don't need it. So now we're gonna bring in our second channel, which is our resistor 2. And we're gonna do that simply by clicking channel 2. And we're gonna turn this menu off so it's not distracting us from any other things. Now we need voltage peak to peak, so we're gonna click this. And you see how this says channel, our source is channel 1? We're gonna make sure that says channel 2, so we get our correct measurements. Voltage peak to peak is under voltage, so we're gonna click voltage, and we're gonna scroll down till we find voltage peak to peak, which is right here. And we're gonna click that, and it's gonna give us some information, which is our 4.72 volts peak to peak. And come down here and record that information down. 4.72 voltage peak to peak. Now we're going to measure voltage RMS. And we're going to go back to the oscilloscope and find our voltage RMS, which is under voltage, and scrolling down. We should find it right about here. I'm going to click voltage RMS. And now our voltage RMS is 1.65 volts RMS. Come down here, we're gonna record it, 1.65 voltage RMS. And now we're gonna move right along and measure our time, which is our period. We're gonna clear the menu so that we know that we're dealing with something else, which is in time. Click time. We're gonna click period, and that's gonna give us the time of wait, which is 1 millisecond. We'll come down here, record our information, our data, and we're gonna move right along to measuring the frequency. Coming back over to the oscilloscope, gonna click time again. Gonna scroll down one time. That's going to be frequency. I'm going to click it, and it gives us 1,000 kilohertz, or 1 kilohertz. Now we're going to move right over here and record our information, which is 1 kilohertz. And then if you take a look again at our new school measurements, they're just about the same as our old school measurements. One thing to note is that the seconds is the same as pure seconds. Only difference being that this is in engineering notation, meaning this millisecond is really 10 to the power of 3, -3 times 1. I wrote that backwards, but the mathematics prove that it is 1.0001 seconds. It's also noted up here as well in our voltage source measurement. So now, gathering our results and our data from looking at the oscilloscope, we're going to take a look at our time and frequency for resistor and voltage source and resistor. They're in engineering notation, and it's noted that the measurements for the old school are in standard notation. We're just going to clarify and verify that these are the same measurements as these. And we're going to do so by going to our calculator, and we're going to take a look at our time our time measurement first for voltage source 1. So it's 1 millisecond, which is 1 second e to the -3, because milliseconds is -3. I'm just gonna hit enter, and we get 0.001 seconds, which is the same as that right there. That checks out. Now we're gonna take a look at our frequency, and it's 1 kilohertz, so it's 1 second e to the +3 equals 1,000 hertz, which is also the same as our old school method. Now doing the same for the below, we have the same numbers, so we can infer that it's going to be the same. Let me just double check though, real fast. -3. So now we have 0.001 seconds, which is also the same as our standard in old school. And now for the frequency in the new school, it's going to be +3, and we get 1,000 hertz, which is also the same as our old school method.